Leon Charles Thevenin was a French engineer and scientist who in 1883, as a result of studying Kirchhoff's current law and Ohm's law, developed his own groundbreaking theory in the electrical engineering field. This theory proposed that any linear circuit, no matter how complex it is, can be broken down into a more basic circuit comprised of only one voltage source, a series resistor, and a load. Now, this has undoubtedly changed the way the engineering world works today, and when moving through questions like this, the theory is pretty straightforward, but there's just a few steps to keep yourself on track, which I'll demonstrate in the next clip.
Now in this example, it's shown how we can take this more complicated circuit and reduce it in order to obtain the Thevenin voltage and resistance, along with the load current. I'll spare you the detailed maths, but the concept remains the same regardless. Firstly, we start by opening the resistor on the side of the circuit we wish to minimize. In this case, it is the 5 ohm resistor on the right hand side of the system. Now by opening that resistor, it enables us to calculate the open circuit voltage between the marked points on the diagram A and B. To find that voltage, which is actually our Thevenin's voltage, we calculate the voltage across the 4 kilo ohm resistor as it is in parallel with the now open circuit, meaning it will have the same value. As you can see on this example, the Thevenin voltage is 12. Now from here, in this third step, we open any form of current sources in order to calculate the open circuit resistance or the Thevenin's resistance. In this example, you can see that entails removing the 48 volt source. Now this leads us to our next step, where we actually calculate the Thevenin's resistance. This step is similar in nature to finding the voltage. We use base level circuit analysis to determine the value. As you can see here, the 12 and 4 kilo ohm resistors are in parallel, so that value is found accordingly, and then added to the 8 kilo ohm resistor to give us a value of 11. Now we have found both the Thevenin voltage and resistance. The hard work is basically done. We now reconstruct a basic circuit using the found values and resubstituting back in the 5 kilo ohm resistor from the start. Now the circuit we have just created here is what is actually known as the Thevenins Equivalent Circuit. Now we have constructed our Thevenin's equivalent circuit, we can now use Ohm's law to determine the load voltage and current.